large. If we're looking at most models we see, if we're dealing with quantities that are not per unit time, it's very clear it's a stock. Very clear it's a stock. If we are dealing with quantities that are per unit time, it probably serves as a flow, but it may also be represented as a stock. You may want to represent it as a, that's fine if you want to. It's just, if we are dealing with some quantity that does not have to be quantified per unit time, if we can measure it, and therefore we can measure it at any one instant of time, it's a stock. Okay? So, we could go through the examples here quite readily. But I'd like to talk about some other components. So within VenSim, we further have auxiliary variables, which are convenient names we have for things. So for example, total population here is a convenient name that we have for a certain quantity. What is that quantity? What would the formula be for total population, do you think? This plus that is not. And prevalence of infection, this is the fraction now of the population that's infected, so we could have called it fractional prevalence of infection. That kind of don't always quantify that as, or don't always explicitly specify it, but fractional prevalence of the infection, what would that be? This divided by total population. And so naming these things is often really convenient for transparency because you may use total population at several places. You may use that quantity at several places, and to give it a name is something meaningful. And we could do unit checking on it, and we could report it, and do a graph of it, and all those sort of good things. So we reuse these things in what are called auxiliary variables. And those are just little formulas of these other ones. But at a deep mathematical level, at the level of the underlying math, the differential equations, these auxiliary variables are just, we can essentially ignore them. Ultimately, it would depend. What matters is how the derivatives of these stocks, which is just the sum of the flows in minus the flows out, depends on the stocks. And you can unpack all of these into their constituent parts, all of the auxiliary variables. We'll be seeing that, but the point is the auxiliaries are convenient for us as humans. They give us nice names which we can reuse, make the model more clear, but at a mathematical level they actually go away when we finally analyze it, if we want to analyze the model explicitly mathematically. And then we'll have constants. We'll have things like recovery delay, the mean time for someone to recover from infectiousness, or the mean time for them to lose immunity. These are constant, okay, within our framework. Okay, so these are constant values. Another constant value we associate with initial values of stocks. What's the initial population? Okay, so we may have, I'm showing here one population divided into stocks. It's worth reflecting the fact that we may have within our model several different populations divided into stocks. So here, for example, birds. Here are birds divided into a set of stocks. Here are mosquitoes divided into a set of stocks. And here are humans. Needless to say, we don't have flows, from people into mosquitoes. You might think when they bite you, okay, they do bite, but there's no flow. Like a person doesn't become a mosquito, Kafka aside, and a bird doesn't become a human, even though you may have heard of Birdman. There's no, what's that? Well, okay, yeah. So if you had amphibians, I guess.
This is not an evolutionary model.
Okay, so moving right along. So that was just models with multiple types of. Whoa, I'm getting lost in my